Woohoo! Welcome back. This is 9.6 part 2, and we are talking about the chain rule. Yay! And in the first video, we came up with, I introduced the chain rule. And the chain rule, I'm not always sure that these little helpful cards are all that helpful, because sometimes this formula is a lot harder than just practicing what it actually means. But I do want to start out with it. So if this is helpful, awesome. If this is not helpful, feel free to focus more on the practice of the chain rule rather than memorizing the formula. But this is the formula. And basically, what we're talking about is we're talking about taking the derivative of a composite function or a complicated function where there's clearly an outside function and there's clearly an inside function. And in the first part of the video, in the part 1, we went ahead and I showed you both the long way and the short way with the chain rule, and we could compare and contrast. And I alluded to the idea that there are some functions where you kind of have to use the chain rule. And so the first one we're going to start off with, in fact, I think all 3 of the ones we're going to start off with, you pretty much have to use the chain rule to take the derivative. Or I suppose you could use the definition of the derivative, but let's not go there. So let me put this down here to be helpful. If it's helpful, I'm going to ask Godzilla and Sharktopus to stand a little bit off to the side. I don't want anyone to get any calculus in the eye. And let's take a look at this function. And the first thing that you should be asking yourself is, do you see this as a composite function? In other words, do you see this as a function that has 2 separate kind of parts? And when I look at this, I see 2 separate parts. And the 2 separate parts are that there's a radical or a square root, and then inside, and there's the key word, inside the square root is the function x squared minus 1. So I've actually got 2 pieces. I've got an inside piece, the x squared minus 1, and then an outside piece, the radical or the square root. And that's key for using the chain rule. So I'm going to go ahead and say, okay, I see this, and I see f of u as being the square root of u. Okay, so this is the outside. Now, to be fair, the outside function won't obviously be the outside function when you look at it. But I think in this case, it looks like the outside. So this works. I'm going to claim that the inside function is this x squared minus 1. This I consider the inside, function. So if you've got an inside and an outside, and you can separate them this way, then using the chain rule to find the derivative is going to be one way to solve it. Now the question for you is, can we take the derivative of this without splitting it up? And the answer is no. I have not taught you how to do this without using the chain rule. So as far as we're concerned, this is the only way to do it, other than the definition of the derivative, and that's not even clear that you could work that out. That would be a lot of work. So let's take a look at how we're going to approach this. So I claim that, let's see, what are my colors? Purple is my outside function, and yellow is my inside function. So in other words, I've got y equals radical x squared minus 1, and the x squared minus 1, there's the inside part, and the radical is the outside part. I'm not sure if that helps or hinders, but let's go with it. So if my f of u is radical u, the first thing to realize is, okay, this is a lovely symbol. The symbol is called the radical sign. It's lovely. It's useful. You've probably been working with this for years. You probably learned it as the square root of something. But in terms of what we need to do in terms of taking derivatives, not really useful. So I'm going to convert this to u to the 1/2. Converting radicals to a rational exponent is really key to being able to do calculus with them. Okay, so that's the first step. And then remember that in order to use the chain rule, we're going to have to take derivatives of everything. So let's do it. Let's take the derivatives. So f prime of u is, remember, if you've got an exponent, even if it's rational, the exponent comes down. Then we take the original exponent and subtract 1. Now, this is a case where, in fact, f got more complicated when we took the derivative. So it doesn't always get easier. But given that this is our only option, we're going to have to go with this. So there we go. That's the outside. This is the purple part right here that we're talking about. Okay. So then we've got our inside function, g of x, which was x squared minus 1. Now, the great news about this one is when we take the derivative, this one's actually really nice and not too hard at all, right? Because this is just a polynomial. Woohoo, let's hear for polynomials. So our g of x, which is this x squared minus 1, the derivative, 2x. Nicely done, nicely done. Okay, so we've got these different pieces and parts. Remember, we've got the f and the f prime and the g and the g prime. We need all of these things. And then we've got our recipe card here that says the derivative. Am I going to be able to fit all this stuff in? Let me scooch this up a little bit. Let's see, where am I going to put this? I'm sorry, Sharktopus. See, I said if anyone gets too close, we're going to put out an eye. I'm going to put Sharktopus over here. He is cheering for us, but just off on the side where he won't lose an eye. And let's scooch this up a little bit. We know that dy dx is equal to the derivative of the outside, f prime of u. Now, you don't have to use the formula. Like I said, if you remember, derivative of the outside times the derivative of the inside. Okay, so f prime of u is 1/2 u to the negative 1/2. And we're going to multiply by g prime of x, which is 2x. So far, so good. Now, here's the downside. Now we got x's and u's running around. So I'm going to go ahead and convert the u back into x. Now, do you remember what u is? Remember what u is? What is u? U is smart. U is beautiful. U is amazing. But u equals g of x. U is just a fancy letter that's going to sit there and take the place of g of x, so it doesn't all get too confusing. I know, you're all thinking, could it be more confusing? Trust me, it could. It always could. This is math. So in place of u, I've got g of x. So I'm going to write u equals. Right, u equals g of x. So that's x squared minus 1. Okay, yes, I agree. This looks really hopeless. But let's put it together nicely. I've got some fraction stuff happening. The 2 is in the denominator. This negative means the square root is down here. But then the 2x is up on top. And, oh my goodness, where's my red pen of destiny? Look at this. This 2 and that 2 cancel. Woohoo! And we end up with this really interesting x over the quantity x squared minus 1 for our derivative. So the answer is, if you take time, you set everything up, you define everything, life is good. Now, is there a way to do this without the formula? Like if you didn't have this magical card written up for yourself? Yes. Basically, what the chain rule does is it says deal with the outside, leave the inside in place. So our original function was radical x squared minus 1. Or, and I can write this up here, x squared minus 1 to the 1/2. So let's take a look at what happened. If you want to take a derivative without using the formula, think outside first, inside second. The outside, the 1/2 comes down, just like it did right there. And then what happens? You subtract 1, you get a negative 1/2. Notice the x squared minus 1 stays put. And then what do you do on the outside? On the outside, you take the derivative of the inside. So what's going on? The 1/2 comes down. You leave the x squared minus 1, the inside the same. You get negative 1/2. And then you multiply times the derivative of what's inside, the 2x. That's why it's considered a chain, because you do the outside and then it spits out another one. At least that's what I think why it's called the chain. I'm not actually sure. I am not quite old enough to have been there when they came up with it. I mean, I'm close, but I'm not quite that old. Okay. Shall we try another one? Can you stop me? Not really. Okay. Again, this one, if you look at it like this, and I say what's outside, what's inside, I could just see you just throwing up your arms and going, I have no idea. How would you possibly figure that out? And I do have a hint, and the hint is write the function with the negative exponent. So the hints will always be get rid of the symbols and try to write it out with exponents. So what's a symbol here? Well, technically a fraction is writing something symbolically, right? It's a symbol that means, you've got the numerator and the denominator. Can we take that out and look at purely what's going on? And in my mind, purely what's going on, if we've got a 3 and a 2x minus 1 all to the negative 2. Okay, that simplifies things, and that tells us exactly what's going on. This is beautiful, and I love it, but it doesn't, it's easy to forget that this is a negative 2. Okay, so what I want to suggest here is I want to suggest we try this 2 ways, believe it or not. So the first way is I'm going to try it without the formula. Am I going to try it without the formula? Yes, let's try it without the formula first. And then we will go ahead and work it out again with the magical formula card. Okay? So without the formula, y equals 3 times the quantity 2x minus 1 minus 2. So what's on the outside? The outside is this and the negative 2. What's on the inside? The inside is this part, the 2x minus 1. Okay, so dy dx. And this is actually how people take the derivative. I got to tell you, after a while, yes, we use this card, you use this formula, you study it, you memorize it, you work so hard. And then after a while, if you're taking a lot of derivatives, you stop using that and you start just doing it, right? This is like when you already have memorized how to make cookies and you can just do it by heart and you don't have to look everything up. Okay, so when you take a derivative, the 3 that sits in front just stays there, right? We don't have to worry about it. So now I've got these parentheses. I've got a negative 2. That negative 2 exponent is going to come down. Now, what happens to the 2x minus 1 at first? At first, it stays the same, right? and then I subtract 1. And then what's the chain part of this? Well, the chain part of this is that this comes out and we take the derivative, and the derivative of that is 2. So let's see, negative 6 times 2x minus 1 to the negative third power times 2. Let's figure out who's on top. Negative 6 is on top, there's a 2 on top, and then there's a 2x minus 1 cubed on the bottom, so that's negative 12 all over 2x minus 1 cubed. Okay? What do you think? So that's what it looks like once you get the hang of it, once you get some practice. Now, will you get enough practice in this class? That is not clear. If you were taking a full calculus class, oh my gosh, you'd be doing so many of these problems. But in this class, we don't have a lot of time set aside for practicing this because this is more of a survey and less of a really dig in sort of class. So you may not get to this point, but I want to show it to you. Second version with the formula. The formula is really formal, and so some people right off the bat are going to hate it, and some folks right off the bat are going to love it. And so it's a hard one. So you'll have a choice. So first thing we have to do, remember, is we have to come up with our f, our outside, and our g, our inside. So my f of u, I'm going to claim as the outside. It's the 3 and the negative 2, and then I put a u inside as a placeholder. And then I have to find the derivative. Okay, so the 3 stays there. This is going to feel very similar. The negative 2 comes down. Then I've got u to the negative 2 minus 1. Okay, so that's going to be negative 6u to the negative third. Okay, now my g of x is the inside. That's this part. Right? And that equals 2x minus 1. So what's g prime of x is, this is going to feel like we just did this because we did, it's 2, right? So we get these 4 things all set up, and then we remember the formula. We take the derivative of the outside times the derivative of the inside. So let me get everybody underlined. Here's my g of x, g prime of x, sorry. Here's my outside function. There we go. Which is going to be right there. Okay, so, where's my pen? dy dx equals f prime of u times g prime of x, which is equal to, right here, negative 6u to the negative third, right there, right, the f prime of u, there we go, times g prime of x, which is 2. Okay, so that's going to be negative 12u to the negative third. Okay, so I got negative 12 all over u cubed, right? But then we don't leave it in terms of u. What do? We rewrite it in terms of x. So I've got negative 12 all over, remember, u is smart, u is beautiful, and u is g of x. 2x minus 1 cubed. Oh, I can't really fit these both in the same window, so let me kind of leave it like that. Take a look at that. So this is with the formula, this beautiful chain rule formula. That's using the formula. And this one's more just outside and then inside. And again, this is the way that eventually, if you had enough time to practice, that would be the way we'd hope you get to. Okay, so we're up at 20 minutes. These are not going to be fast problems. I believe I have, let me double check. I believe I have one more chain rule problem, and then we get to do the power rule, which, I mean, honestly, It's the chain rule. So we're going to do in the next video, hopefully 2 more problems. Let's see how far we get. But for this video, woohoo, you guys have made it. Congratulations. You are amazing. Kiss your brains. Go look at something far away. Give yourself a rest. And then come on back and I'll see you for video 3. Math on. Woohoo.